Hi, I am Rajendra Kulkarni. Welcome to my channel Programming in C with RSK. Friends, I have already uploaded nearly 25 videos explaining various aspects and topics in programming in C. Each video consists of at least 3-4 programs. Please view those videos, like those, subscribe to my channel and share with your friends. Today in this video we are going to discuss about arrays in C. What is an array? Array is a collection of similar data under one name. Friends, we have already seen various variables. We have used various variables in our earlier programs. In all those variables, we can only store one value in an int variable or a char variable or a float variable. Cannot have more than one value stored under one name using the variables. Array, it is also called a subscripted variable, is a collection. We can store large number of data, more than one number, and a huge data can be stored in thousands in an array under one name. The only limitation is the data must be of the same type. So we can say array is a collection of similar data under one name. Each of these data, individual piece of data which is stored in an array, can be accessed through its position in an array. What is the position that we will see? How array is declared? Here we have declared an int array which tells the compiler that this array will be used for storing int values under the name of ABC. ABC is the name of the array, and how much data that array will be holding or storing under its name, it is given by this subscripted number 10 within the subscript. So what this declaration tells, it creates an array of int values under the name ABC which will hold 10 int constants under one name ABC. So when an array is declared, first its data type has to be declared, then its name can be anything, and then the dimension. The value written within subscripts is also known as dimension of the array. Dimension of the array tells to compiler that this array which we have declared will be holding this number of constants belonging to a int or a char data type or a int data type or a float data type or even a pointers also. In this particular example, we have declared int ABC and 10 as the dimension of the array ABC holding int constants, 10 numbers of int constants. We can declare arrays for all the data types available to us in C, floats, chars, pointers. One by one we will see all these. The only limitation of an array is it can hold only the declared data type constants. A int will always hold int constants. A float array will always hold float constants. A char array will always hold char constants, and a pointer array will always hold pointers. Mix of these data into one array is not possible. How array is declared? Int arr5 is equal to these numbers 1956, 90, 2045, each separated by comma and within the braces, and there is a semicolon. So int arr5 is declared as an int array which will be holding maximum 5 int constants, and those int constants, 5 int constants, have been initialized. The array has been initialized with the 5 int constants which we have done in this statement. It's called declaration and initialization at the same time. Int abc 5, subscript 5. So it is a int array named abc which will be holding maximum 5 int constants, and this is the declaration of the array. We have not initialized it here, we have only declared the array. The initialization abc subscript 5 is equal to 1 2 3 4 5 is not allowed. This will flag an error, because in arrays, once the array can be initialized only when it is declared in this fashion by assigning values to it. Now this is a float array called num, which is having various float values which we have assigned to it in the statement. Now how this array is arranged in the memory? All the arrays are allotted a memory locations decided by its data type and its dimensions. So if it is an array of int with 5 dimensions, then every int constant is stored in 2 memory locations. So compiler will allot 10 memory locations for array abc. In case of float num array, we have declared dimension of 5, but all the constants which we will be storing in this array are of float type. Each float constant is allotted 4 bytes in the memory. So when the array is declared and initialized in this fashion, what compiler will do, it will allot 20 memory locations, because 5 float constants will occupy 5 into 4 is equal to 20 memory locations. Array elements are always numbered from 0. So when we say and a float num dimension 5, the array of 5 float variables or float constants, they will be numbered starting from 0 to 4. These are the values which we are assigned to each and element of the value of the array in this statement. Element number 0 is allotted with 2.4 value, assigned with 2.4 value, not allotted. The element 0 is assigned with 2.4. Element number 1 is assigned with 5.6. Number 2 with this much, number 3 with this much, and number 4 will be 3, 4, 5, 6, 7.89. These are the values we are assigned to individual elements of the array. What memory locations being allotted? Suppose compiler allots 100 as a starting address for this array, which will be holding 0th element, then 0th element will occupy memory location 100 to 103. Element number 1 will occupy memory location 104 to 107, and so on till memory location 113 to 119 are allotted for num arrays fifth element, that is element number 4, in which the value assigned to that element will be stored. Array elements are stored in contiguous memory locations. It is a very important thing to know and to keep it in mind that whenever array is assigned or declared and assigned, compiler will allot contiguous memory locations for its elements. So if an array of float is of dimension 100, compiler will allot 400 memory locations for it. If an array is declared with 500 char constants as its elements, compiler will allot 500 memory locations for it, and all will be in contiguous locations. So why this is done, that we will see later on. Accessing the array elements. Now we have seen that when an array is declared and assigned the values at the time of declaration only, it is okay, it is allowed. But when an array is declared after its declaration, the initialization after declaration is not possible in the way we assign values to the array num in this particular program. Now how to access each constant stored in an array? It is simply by subscripts. Num and into the subscript 0, num 0 will be pointing or will be accessing the first element of the array, which happen to be having a value of 5 stored in it. Int constant 5 stored in element number 0 of the array num. Then num1, num2 and num4. So in this way, if we try to display the values held by an array or assigned to an array, this printf statement will work on the array, take out the values from the array and display those values on the screen. So int array having name num and dimension 5 is declared and assigned. Array is initialized. Assignment of a array, the values to array, is also called initialization of the array. And num subscript 0, num subscript 1 are the way array elements are accessed, and this printf statement will give this output, the screenshot of the output screen when I ran this program. Num0 is equal to 5, num1 is equal to 10, and lastly num4 is equal to 3. Array elements are accessed using its name and element number, where the element number is written within the subscripts. First element in an array is always numbered 0 by the compiler. We cannot change it. first element will always be numbered 0. First element is always the 0th element of the array. Once we have declared the array, we know either we can initialize it at the time of declaration. Once it is declared, then we cannot simply initialize it by putting a value to it as we have done earlier. How to initialize array and populate array after declaration? A simple loop with printf and scanf statements in it, functions being statements using functions printf, scanf. Here we are declaring a num array int num 5. 5 is the dimension. Then 2 I and j are the two variables declared. Then a for loop which goes up to I is equal to 4, and a statement, printf statement, prompting user to input a number, type a number on his keyboard, and that number is being assigned to the array elements through this statement scanf %d and ampersand num into the subscript I. So as the i's value will change, the array element will be accessed as per the value of I at any given time when the loop is running. So when the loop starts, I is 0. So the first number that the user will be inputting will be assigned to 0th element of the array num, because I will be holding a value 0. So and num 0 will be the element, 0th element of array num, which will be assigned with the first number that has been input by the user. Similarly, when I becomes 1, element number 2 will be assigned with the input, and so on up to element number 4. So when I is equal to 4, the fifth element of the array num will be assigned with the value that user will be typing in or putting in through the keyboard. This is the way how a data is entered in an array using keyboard. A user can enter a data, can initialize the array using a keyboard and a scanf statement. Now this printf simply displays the numbers entered or the values entered by the user. So when I ran this program, it prompted me this first for loop. This prompted me in every iteration to enter any number of type int. I entered 10. In the second iteration 14, 18, 40 and 56. So all these numbers, all the values or all the int constants which I have entered will be assigned to the respective elements of the array. For 10 will go to element number 0, 14 will go to 1. In this way 56 will go to element number 4, which is in fact is the fifth element of the array, and this printf statement tells us whether the numbers are really assigned to the array elements or not. So this loop accesses the array elements by the subscript notation num subscript I. When I is 0, element number 0 will be accessed and its value will be displayed. when I is equal to 1, element number 1 of the array, which is the second element, will be displayed. In this way, the fourth element or the fifth value will be displayed when I is equal to 4. Array elements are always numbered from 0. How array elements are stored in the memory? We have seen they are stored in a contiguous memory locations. So this program just tells us what are the memory locations where the element number 0 to 4, all these 5 elements of the array ARR are stored. So this printf statement gives us or displays the value of the elements, and this ampersand ARR subscript I, this gives the address of that particular element. When I is 0, it will give address of ARR element number 0. When I is equal to 4, it will give the element number 5's address. So this is the way the function, this program gives the output in the output screen. So element number 0 is equal to 1 because we have assigned 1 to the array. We have initialized the 0th element of the array with value 1. Then 4, 7, 9 and 10. Look at the addresses of each and every element. Address of 0th element is 65516. Then next element is 18202224. So they are all on contiguous memory locations. So this is simple map of the memory, which is actually a conceptual map. 65516 and 17 hold the value 1, which is the array element number 0, and 2425 holds the value 10, which is the array element number 4 in this ARR 5 array. We can see here we have not mentioned the dimension. So when the array is initialized at the time of declaration, there is no need to mention its dimension, because the compiler will come to know about its dimension when we are initializing it within the opening and closing braces. So it will count how many constants are put into the opening and closing braces, curly braces, and that will be taken as a dimension of the array by the compiler. We can also declare an array of char, a simple program, char array 5, char, I have given name CARR to this array with dimension 5 and initialize with char constants a, b, hash 9 and a sign equal to. And when I have to access the array elements and display the elements of the array, I use a loop for I is equal to 0 less than 4 I plus plus, and printf char CARR %C I and char I. So CARR 0 is A, CARR 1 is B. In this way CARR 4 is the sign of equal to. The array once declared and its dimensions are given, cannot increase the dimensions. It is called bounds checking of the array. In this program we will see how bounds are checked. The float array num initialize with 4 float constants, then a printf statement which gives us the value of each value stored at each array element and the address of those elements. In the second loop, what we are doing is for I is equal to 0, I less than equal to 5. Actually, the array num has the dimension of 4. But here we are trying to take out the values stored in 6 elements of the array num, when actually the array num is having only 4 elements declared with dimension of 4. So can this work? Well, the compiler doesn't throw an error. Compiler will straight away compile this program and we can run this program without any hindrance. The only thing is, what are the outputs of the second printf and I loop when it is trying to access 6 elements in an array which is only declared as having 4 elements or dimension of 4. Num dimension is declared as of 4 elements. It is written 3 here. Number 3 is the element, last element. Actual element numbers are 4. In the loop we are trying to access 6 elements, not 5. Element number 5 will be the 6th element of the array which we are trying to access. So when we use this kind of program where we are trying to access the elements of the array which are not assigned to it, the compiler doesn't complain, program runs. The only thing is, when we exceed the bounds of the array, dimension of the array we can also say as bound. When we try to exceed the bound of the array, the program may give us unpredictable results because the compiler has allotted only 4 locations, 4 into 4, that is 16 locations for this, and we are trying to exceed the locations 16. Instead of 16, what we are trying to do is to access locations 24, number of 24. 24 locations we are trying to access in this for loop. So what will be available in the 8 memory locations for or the 2 float values that this loop will try to access? It will have either a garbage value or some unpredictable value. When I ran this program, the first 4 elements are legal, in the sense that is the dimension of the array. So I got the correct values in the loop, first loop where I is less than equal to 3, in the second loop where I is less than equal to 5. 4 elements came out or displayed correctly, element number 0, 1, 2 and 3. For element number 4 we got 0, for element number 5 we got 0. The addresses are 10 to 22 are the legal addresses which has been allotted to this array num by the compiler. This 26, 30 will have some garbage value or some other value which we never know what will be, but it will be displayed by the printf statement. In this case it's only displaying the value, it's not making any harm in our program. But if we use an array for certain type of calculations or some certain type of arithmetic procedures using the array elements, if we try to exceed the bound, our program will make crash instead of running smoothly. So that care of remaining within the bounds of the array has to be taken by the programmer. Compiler doesn't look at it. Now this is a program where I am trying to make three arrays. First array will be an array of 10 int constants. The second array I want to create is a must have odd numbers from within these 10 numbers assigned to array, and another array called even will have to hold even numbers only. Now in this for loop, arri is being assigned with a number created by the function random into the bracket 100. It is a library function defined in stdlib.h file. This 100 tells the function random to generate random numbers from 0 to 99, and every time the loop iterates, one random number will be generated and that number will be assigned to array arr elements. So when 0 I is 0, arr 0 will be assigned with some random number between 1 and 99 generated by this function random. Then I am running another loop. Once the arri has been populated with 11 number of elements from 0 to 10, numbered 0 to 10, what I am doing is I am checking whether the value stored in an individual element of the array arr is odd or even. So arri with mod 2, modular division by 2, if it evaluates to 1, it means the number in that particular element is an odd number, and that will be collected in a variable in the array which I have named as odd into its individual elements. So this if arri mod 2, this if conditionally populates the array odd with odd numbers. The name of the array I have given is odd. If the value of arri mod 2, if arri mod 2 expression evaluates to 0, it means the value stored in that particular location of the array is a even, and that will be stored in the array named even. And this for I equal to 0, this loop gives us what are the elements of the array. Then next loop gives us what are the elements stored in the odd array, and the next loop gives us the value stored in the elements of the even array. So when I ran this program, I got three outputs: 1, 0, 33, 3 up to 94. These values are generated by the random function and assigned to array ARR. This 133, 335, you can see odd array. It contains all odd constants. 0, 0, 0 is a neutral one, so it is also being taken as an odd constant. Even array, the array named even, is having only even constant assigned to it. What we had done is we had declared the arrays odd and even as static arrays. Why static arrays? Because when an array is declared as static, its elements are set to 0 by the compiler. We need not have to put it, or we need not have to assign values 0 to those. That is the reason why array are odd and array even has been declared as static. We have up till now accessed the array using subscript notation. We can also access the array elements using pointer notation. So what we will see in this slide is what is the pointer to an array and how to use it for accessing the elements of the array. A array of int constants, 4 numbers, int arr subscript 3 declared, and we have also declared two variables I and sum. We are asking the users to give the number or give the data which will be assigned to the array ARR. It is having a dimension 3, so it will be storing 3 int constants, and through this for loop, the user will be prompted to input the constant you want to assign to the array element. So scanf %d ampersand arr I. This causes the entered number to be assigned to array elements ARR 0, 1 and 2 as the loop iterates. Then we are trying to make the sum of the elements of the array, all the elements of the array in this for loop. For I is equal to 0, I less than or equal to 3, sorry it should be 2, 3 is wrong. I plus plus sum is equal to sum plus indirection operator now star into the bracket name of the array ARR plus I. So what this statement will do, in every iteration the value stored in the array element number 0 or 1 or 2 will be accessed and added to the variable sum. Then this declares tells the sum. This printf displays the sum of the array. We have entered 1, 2, 3 as the numbers into the array, assigned values to the array element 0, 1 and 2, and their sum is 6. What is different in this program is we are taking out the value stored in the array elements using a value at address operator star. This statement will give or will access the element, individual element's value through pointer notation. Where is the pointer here? We have not declared any pointer, but what C compiler does is it assigns the address of 0th element to the array's name. So ARR is the name of the array, and ARR is also pointer to the 0th element of the array. How we are accessing the array elements in this statement? Sum plus value at address ARR plus I. What this ARR plus I does? ARR is replaced by the address 0th element of the address, and as the I value changes, when I is 0, this star of ARR plus I will point to and take out the value of element number 0. Then when I is 1 in the next iteration of the loop, ARR is the starting address, it remains same, to which 1 is added. So the pointer now starts pointing to the next memory location where the element number 2, or the first element of the array, element number 1, because 0 is the first element. So when I is equal to 1, it is pointing to element number 2, and then again when the loop iterates, I value changes from 1 to 2. So the third element of the array will be accessed through its address by this star of ARR plus I expression, and then this printf statement gives the value of sum of the array elements. What we must keep it in mind is name of an array is itself the pointer to the address of its first element or base address, or in short, array name is assigned with the address of the 0th element, base address of the array. We have seen that name of the array itself is a pointer to the 0th element of that array. Now when we declare an array, what compiler does, the name of the array is stored as a pointer which is pointing to the address of the 0th element of the array, but compiler also take care that it is a const pointer. Compiler creates a const pointer. Const pointer means the pointer whose value, that is the address stored in it, can never be changed. So when array is declared, compiler creates a const pointer having the name of array and assigns it with the base address of the array, or the address of the 0th element of the array. What will happen if we will try to access the value of array through its name as a pointer, and we will try to increment the pointer to access the various elements of the array that we will see in this slide. We have declared an array ARR, int array ARR, and assigned with certain values 1, 2, 3 up to 10. Then we have also declared an int pointer, int star ptr, and int I is equal to 0 has also been declared and assigned. Now what we are going to do through this for loop, for I is equal to 0, I less than 10 I plus plus, we are trying to access the values of the array ARR, all the elements of the array ARR by using the value add address operator star or indirection operator star. So when ARR is having some is assigned with the address of 0th element, to that every time we increment, we add I, the value of ARR doesn't change, but ARR remains what it was assigned with, but this I plus I causes the whole expression to point to the next memory location where a int value will be stored as a element of the array. So star ARR plus I will give us the value stored in every element from 0 to the last element of the array, and it will be displayed by this printf statement on the screen. Now I am trying to get the values of each and every element. Here I am using star of ARR plus I. What if I want to get the values of the progressively incrementing the pointer by the expression ARR plus plus? When I try to do it, the compiler throws an error because ARR being a const pointer, its value can never be changed, should never be changed. And this expression is trying to change the value of a const variable, which is not allowed, that is why these statements or a for loop where I am trying to increment the value of ARR will not be compiled. It will be compile time error will be thrown by the compiler. Now here what we are doing, PTR pointer which we have declared as the int is being assigned with ARR. Look again, we are not assigning ARR with ampersand. We are not attaching the name of the array with ampersand, which we normally do when we want to take the address of a variable. But in case of arrays, ARR itself is holding a address of the 0th element. So we are not using ampersand here. We are directly assigning that address with this assignment statement to PTR. And when PTR can be incremented because it is not a const pointer, it has been a simple pointer which we have declared. So star of ARR plus I, this expression accesses the value of elements stored in array ARR using the pointer notation. As ARR is a const pointer, its value cannot be changed. When program attempts to change its value, an error is thrown by the compiler at compile time itself. Program will never get compiled. Here PTR is equal to ARR, we are assigning the address of 0th element of the array to a pointer PTR, and through that pointer we can access the values of all the elements of the array. Because PTR is not a const pointer, what PTR is equal to ARR does, ARR is holding a value which is the address of the 0th element, and that address is assigned to PTR. And since PTR is a normal pointer, it is not a const pointer, its value can be incremented, changed, and we can access the values of ARR elements using star of PTR and PTR plus plus. Then pointer to array of characters. a small program char zz is the array of type char declared with a, b, c and 3 as the assigned constant to the elements of the array. We are declared j as a char pointer to which we are assigning address of 0th element of array zz. By this expression j is equal to zz, and by using that pointer j we are accessing the values and also the address of each and every element of the array zz. So this is the screenshot of the output I got when I ran this program. So this is all about arrays. We have seen int arrays, we have seen char arrays, we have seen float arrays, we have seen how to access array elements using subscript notation. We have seen how we can access the elements of the array using address of the array. We have also seen that the array name itself is the pointer to the 0th element of the array, and we have also seen that the name of the array is a const pointer. We cannot change its value. So this is all about arrays. Friend, this is the 24th or 25th video I am uploading. All the videos I have uploaded up till now explain various features of C, such as constants, variables, if else, switch, loops, pointer, functions and many more. My upcoming videos, a few of the topics which I have mentioned here. What is C preprocessor, what are graphics in C, storage classes and so on. So please keep watching my videos. Thanks for watching this video.